This lecture will explain the rule of distribution. We'll start with the rule of distribution for and. So the way the rule of distribution for and works is if you have some formula that is a conjunction and one of the conjuncts is a disjunction, and actually you want it to be the conjunct, we want it to be the right conjunct. So if you have a formula of the form Q or R and P, you can't do disjunction on that until you do commutation. You have to do commutation first if it looks like this formula, because it needs to be set up this way just because it would get confusing otherwise. Okay, so how the rule of distribution works is, so if we have this formula P and Q or R, that's going to transform into, I'm going to write it down here below. It's going to transform into a statement that is a disjunction. So if you've got an and as the main connective, you're going to end up with an or as the main connective. And then the left disjunct will be whatever letter is right here, the P, and then it will be the left disjunct of the disjunction joined by an and. So see, you started with and as the main connector and as ors as a sort of subconnector here. We're going to end up with something with ands as the subconnector and or as the main connector. Okay, and then the other side of the disjunction will also have the P, and then it will have the right disjunct. Does that make sense? And if we want to work back the other way, then we need to have a formula that's set up this way. You need to have the formula that's in common between the two sides of the disjunct be on the left-hand side. So if you have a formula like, say, Q and P or R and P, you can't do distribution on that. You have to do commutation on it so that it looks like the formula here, and then you can do distribution on it. Okay, so now let's look at the rule of distribution for or. It works basically the same way. It's just that the ors and the ands are in different places. So distribution for or works on formulas like this: P or Q and R. So it works on formulas where you have a disjunction and the right disjunct is a conjunction. And that is going to be equivalent to an and statement whose two conjuncts are P or Q and P or R. So it goes from being a statement that is overall a disjunction, but one of the disjuncts is a conjunction, to a statement that is overall a conjunction and has two disjuncts as its conjuncts. I know, that sounds confusing, but hopefully you were following that. And likewise, they have to be in the right order. So the thing that's in, if you're working in the expanded form and you're trying to go to the expanded form, you could say is this one, and this you could call the contracted form. I believe that's what your text even calls them. We're just going to call them all DISTR is going to be the abbreviation we're going to use. We're not going to worry about if it's or and. I'll be able to figure that out. And we're not going to worry about if it's the contraction version or the expansion version. We're just going to make it simple and call them all DISTR, I guess we will pronounce that. Or you could just say distribution when you see that abbreviation. So you have to have the thing, So if you're working in the expanded version, you need to have the thing that's in common between the two sides of the formula be on the right-hand side, on the left-hand side, sorry. And if you're working in the contracted version, you always take what's on the left-hand side and you distribute that. Let me show you an example that's a little weird, but works. So if you have the formula P and Q, or Q, no, let's just do something else. Let's use other letters entirely. Okay, R and S. Now this might not look like a candidate for distribution, but in fact it is. This is just your P. So how you would do distribution on this is you would write P and Q, so you keep that all as a chunk, or R and P and Q, or S. So you can do that also with, formulas that, the AND version. So if you had P or Q and R or S, you could do the distribution on it the same way, except that, of course, it would end up with, well, let me just do that. Let me do that on another page. So we could do, it's easier to do than to sort of talk about it in the abstract. So if we had the formula P, what was I going for? Yeah. P or Q and R or S, well then this is your P now. That whole formula. So then you go P or Q, the whole formula just comes along for the ride. And so when you're doing the distribution, you can take whatever the connector is here and you're going to put it in your distribution. And then you're going to make your main connector the other. So if you're starting with an AND, you're going to move to an OR. And then we have P or Q and, S. And now we could actually do distribution inside this formula. If we did, we'd need to do commutation first. So we need to first go R and P or Q. Let's just do it on one side. And then we could do R and P or R and Q or we're just going to leave this side alone. So you can see you can very quickly get some fairly nasty looking formulas. You got to make sure you keep all your ducks in a row. So now the question might occur to you, why is this a useful rule? And I'll tell you, this version here is not really that useful, usually. Maybe sometimes, but not that useful, because you can see very quickly it turns into these big, long OR statements, which you can't do a whole lot with. However, this version is super useful because it gives you a way to take a big disjunction and break it into two little disjunctions that might be easier to work with. Maybe you only need the disjunction P or Q. Maybe you only need that part. Or you only need the P or R part. Or maybe you need both parts, but they're useful separately. So that's the main place I use it, is turning an OR statement into an AND statement. So you'll have to see how, if and when you find it to be a useful rule.